5 to 10 years ago. Space news, believe it or not, grew organically. I never intended when I started streaming to be talking about spaceflight for 4 hours every day. Yeah, never intended it. Yeah, I never intended for that to happen, to be honest with you. People started asking me questions about what was going on in the spaceflight industry all the time, so I figure I make a devoted segment. And as the space news cycle got bigger and bigger and bigger and bigger, it just ballooned. Yeah, wait, what? Oh, I did it backwards. That line needs to go in right there, doesn't it, Fig? Ah, that's an easy fix. Okie dokie. That's alright. We can fix that. That's no problem. So you guys like the Minecraft stuff. I stream it every Saturday. Every Saturday is where we're at. Okay. Alright. So, let's, I'm going to clean up the tabs here. Let's get SpaceX up and running. And then after that, we have some GTA racing. So, okay, SpaceX is live. Here we go. I'll switch us over to the Turksat-5. Turksat-5B. SpaceX Falcon 9, Turksat-5B, launch coverage. Switches over back to science and technology. There we go. All right. Yeah, Tiggs, it's pretty good. BTA bracing. Looks like a Falcon 9 launch. I wonder if these SpaceX people are any good at this. Yep. Which direction is this heading? Turksat-5B, I believe, is going to geostationary, so they should be launching due east. This most likely is super synchronous insertion. It also is going up, yes. Mm-hmm. Hey, where does this rocket go? It goes up. If the rocket goes down, you're having a bad day, or you're coming back. If the rocket goes down during launch, I mean, well, in some certain cases, that's, Give me 1 second. Certain scenario, the upper stage actually falls a little bit before it goes up, but that's not going to happen with this mission. Hey Everest, what's going on? All right.
Discovery,
The
go and throttle.
webcast should be coming up, actually, like right about now. Tired, Everest? Yeah. Hey, Concrete, 23-month resub. Hey guys. Hey guys. Hey guys. Ready?
LWO1 WeatherNet. Liftoff conditions been pretty good.
TS is ready for launch.
It's pretty coggers.
Ignition. Liftoff.
Falcon 9 has cleared the tower.
What's the mass of each one of those engines? About 2 tons, so 2,000 kilograms. Which is insane considering they make
10, 9, 8,
Side booster ignition.
it's pretty nuts
4,
with the Raptor engines, guys,
2, 1.
because they make, actually it's probably a little bit less than 2 tons, maybe
Discovery,
1,500
go and throttle.
kilos, and they make 2,000 pounds of thrust, which is
Hello
unreal.
everyone and good evening. It's Saturday, December 18th, and you're watching the live webcast for the Turksat
Hey, in the
5B
mission
mission for our customer
Welcome to Mission
Airbus.
Control. You go at
My
throttle
name
up.
is Ian McCullough, and I'm a
What up,
sales
Ian?
manager here at SpaceX, joining you from our headquarters here in Hawthorne, California. Just 15 hours ago, we successfully launched 52 satellites from Space Launch Complex 4 East at Vandenberg Space Force Base, and we're back again joining you all for the launch of Turksat-5B. Turksat-5B is a communications satellite that was designed and manufactured by our customer Airbus. The satellite will provide broadband internet services to Turkey and various other parts of the world.
Discovery, go
We're
and
having a
throttle.
Most
busy
of the
few
time it's
days as we are also
proprietary,
gearing
Alex,
up
but you
to
can't
support
really
the
see anything in that
CRS-24
shot.
cargo resupply mission to the International Space Station on Tuesday, December 21st at 5:06 a.m. Eastern Time.
Jim, your astronomer
Before
is showing.
we explore more into today's payload, let's take a closer look at the Falcon 9 vehicle supporting to today's mission. On your screen is a live view of Falcon
Ian's hosted
9
before,
awaiting its
Jake.
10:58 p.m. Eastern Time launch from Space Launch Complex 40 from Cape Canaveral Space Force Station in Florida. Falcon 9 is our 2-stage liquid-fueled launch vehicle and stands 230 feet or 70 meters tall, which is greater than the wingspan of a 747 aircraft. The bottom 2/3 of the vehicle is the first stage. Most recently, we successfully launched a reflown booster for a record-breaking 11th time during the Starlink mission earlier today. As you can tell from the re-entry soot, it's pretty easy to spot a flight-proven booster. Tonight will be the 3rd flight for this particular first stage. It previously supported NASA's CRS-22 mission in June earlier this year, and Crew 3 only last month. At the bottom of the first stage, there are 9 Merlin engines that will get the F9 off the ground and up to the thinner parts of the Earth's atmosphere before separating from the second stage and making its way back down to Earth for landing.
I played RimWorld
And it's
King.
part of the rocket that we will attempt to
hate that
recover
game.
for a 3rd time on our drone ship, a
That game
shortfall
is
of
very
gravitas.
real.
About 2.5 minutes into flight,
yeah.
the first
I know about
and
RimWorld.
second stage will separate,
There we go.
and the second stage will ignite its single MVAC engine to carry the Turksat-5B spacecraft into a geostationary transfer orbit.
Hey, fellas.
The Turksat-5B satellite is
I don't
currently
remember
safely
Falcon 9's
enclosed
second
inside the
stage vents being
17-foot
right
diameter
there.
payload fairing,
Unless
which is
it's
the
just the
structure at the very
wind.
top of the rocket you see on your screen.
I don't remember
This protects the
those vents are
satellites from
usually there.
aerodynamic heating, loads, and contamination during
Or am I
ascent.
crazy?
Once we reach the vacuum of space, we will jettison the fairing halves while the second stage continues onto orbit. The fairing halves we are using today are flying to space for the 2nd time, both having
No,
previously
619. This one's
supported
going out
the
of Florida.
GTS-3 Space Vehicle 5 mission in June earlier this year. And we will be attempting to recover them today using our recovery ship, Bob.
Good evening. I'm John Inspucker, Falcon Principal Integration Engineer, joining you from the webcast desk in
very
Hawthorne,
nice.
California. The launch and satellite vehicle teams are ready for launch as we approach T-minus 12 minutes to liftoff. Falcon 9 team was on console and received their countdown briefing at T-minus 2 hours. Final vehicle checks began at the flight termination system and the Merlin engines on both the first and second stages. And most recently, we completed the poll to proceed
go,
with
Rob.
propellant load and launch. This was at T-minus 38 minutes, and all 7 members of the launch crew were go. Our team began loading propellant on time at T-minus 35 minutes. Falcon 9's first and second stages used the same 2 propellants. One propellant is fuel, the second propellant is an oxidizer. So Falcon 9's fuel is RP1, a refined form of kerosene. Now to burn the fuel, we need an oxidizer. In the lower portion of the Earth's atmosphere, oxygen makes up about 21% of the air that you breathe. So most fires never need to worry about supplying an oxidizer. It's supplied by the oxygen in the air. However, there is no atmosphere in space to provide oxygen molecules, so rockets need to carry their own. And our oxidizer is super chilled liquid oxygen called densified LOX. The liquid oxygen is chilled well below its boiling point, and that increases its density, allowing us to load more into the first and second stage LOX tanks. Now, Falcon 9 carries over 1.1 million pounds of propellant at liftoff. You can see her on the screen. And we burn off most of it in the first 8.5 minutes.
Everest, thanks for the
Now, all of that propellant goes through the 9 engines on the first stage and the single engine on the second stage. Now, later in flight on the second
You're behind. Okie dokie.
stage engines. That's because the second stage engine only operates in the vacuum of space, while the first double up to vacuum.
He's talking about just the different types of engines. There's a single engine in Falcon 9's second stage called a Merlin vacuum. And then there's 9 engines in the first stage called Merlin 1Ds. The reason why there's 9 in the first stage and why there's 1 in the second is because the first stage is really designed to overcome the force of gravity. The second stage is designed to go fast. So think about it like this. First stage go up, second stage go that way. Because when you fly in a rocket, that's basically what you want to do. You need to go up first and then that way. And you need to make sure that your second stage accelerates you to 17,500 miles an hour. If it doesn't, you're not going to stay in space for very long. So the reason why this has a lot more engines on it is because this needs to overcome the force of gravity. It needs to go up. It takes a lot of engines to go up. It takes a lot of force to go up. It doesn't take much force to speed up. So that's why most rockets have 1 or 2 engines in the second stage. I mean, there has been other rockets that have 3. The Space Shuttle's 3 main engines, or three engines for the upper stage. Saturn V had 5 in the second stage, and then 1 in the third stage. So you generally have less engines. Generally, you have less engines in your upper stage than you do with this stage because you're just trying to go fast. Pudding rocket has 4 in the upper stage. About 20 seconds behind. Okay. I don't think I am. I'm sped up as fast as I need to be. It's not going to go any faster unless you want to really hear this thing fast forward. Yep, see? Nope. We're going to fast forward. Fast forwarding. Fast forwarding, sir! For the children. 42 degrees east is its geostationary slot, guys. So, satellites that are in geostation... I can't do it. I can't do it, man. I can't do it. No. Am I gonna get DMCA'd for this? So the slot on a geostationary satellite refers to the point that it's hovering over on in reference to longitude. So this is 42 degrees east. So you're 42 degrees longitude east past the past 0. So there's 0, 0, right? 42 east. 42 west would be out over the United States somewhere. That's how not global positioning satellites. That's how geostationary satellites are assigned. They're in slots, and those slots chlorinate. It's a pool, right? They correlate to latitude on the map.
But we probably can see the arms start to open. And then once the arms are open, the strong back will move about 2 degrees away. And then once we're at launch, ground hydraulics will move the strong back to a position about 45 degrees away.
Fun fact, did you guys know that the Titanic's pool still has water in it to this day? Yeah, there's your fun fact.
Loading to complete at about T-minus 3 minutes.
Like
Second stage will complete a minute after
Scorpio,
that.
7-month resub. Wow, no way!
Now, 1 minute before liftoff, you're going to hear the announcement Falcon 9 is in startup.
Okay.
Now, this announcement means the rocket's first and second stage computers are now controlling the launch countdown on the Falcon 9.
No more chlorine.
Now, at about T-minus 2 seconds, we'll light the 9 engines on the first stage.
I did know
Once the engines are confirmed to be at full power, the flight computer on the second stage will command the ground hold downs to release the rocket right at T0.
Stage 1, LOX load complete.
Okay.
We've heard the call out. Stage 1 LOX load is complete.
First stage is topped off.
We're on time, coming up at T-minus 3 minutes and counting.
I agree. It's a nice saltwater aquarium.
Now, the satellite team is continuing to monitor the status and health of the Turksat-5B payload located inside the fairing on top of the second stage. Now, all the systems are go on the satellite. And the satellite did switch from ground power to its internal batteries at T-minus 16 minutes.
Okay, they cut her off from the grid.
Coming up on T-minus 2.5 minutes shortly. Everything continues to look good. We're still loading liquid oxygen on the second stage. Now, currently the range is green. The air and sea space, as well as the area around Complex 40, they're clear for launch. And on the weather front, as we talked a few minutes ago, the good news is we don't have any weather that looks like it's going to hold us. But if we did have a weather rule violated, we cannot stop and try to launch later. But the good news is the weather looks good for launch. Now, if for some reason we have to call a hold on today's launch, we have a backup opportunity scheduled tomorrow at the same time. All right, now we're waiting to hear the call out for Stage 2 LOX load complete.
Stage 2, LOX load complete.
There we are. So we've closed out propellant loading on all stages.
Should see the TE
start purging out the gases now.
This thing over here.
Begin what we call blowing down or purging the liquid oxygen propellants out of the strong back that we're going up to the second stage. And then we'll be venting down pressure in the strong back.
Okay, so they're doing a gas closeout now. What that gas closeout is indicative of is them getting all the fuel and oxidizer out of the fuel lines that are in the transporter erector, the TE for short. So the second stage, you just heard them say, oh, second stage has a full tank of gas. It's not gas, it's liquid oxygen and kerosene, RP1, right? But they want to get all the fuel out of the transporter erector. And the liquid oxygen is cryogenic, so when they vent the liquid oxygen overboard, it turns immediately into gaseous oxygen. And that's what this white cloud is that's kind of going away from the vehicle. You do not want fuels inside of your launch pad when your rocket goes to launch, ideally. You want to get the fuel out of there. Because oxidizer makes things blow up very, very good. Yeah, very well. I know that's the right way to say that. It makes it pop really easy. You don't want that on your launch pad because when your rocket goes off of the launch pad, right, it gets a little warm. and, you know, warm, you got heat, you got liquid oxygen, and you have stuff that liquid oxygen likes to make explode. Yeah, you don't want fuel in the pad. That's why they do that closeout there. I'm unmuting. Let's go.
10, 9, 8, 7, 6, 5,
Sound suppressors
4,
are on.
3, 2,
Engine ignition.
1, 0. Ignition. And liftoff.
Good. Separation looked good. Yeah, see, part of the pad got hosed a little bit, but no fires from the pad. Everything's good.
Stage 1 chamber pressure is nominal.
Propulsion officer is reporting good chamber pressures on the first stage. That's 9 engines working well. Okay. Next call in the flight should be maximum dynamic pressure.
T plus 40 seconds, Falcon 9 has
He's gonna say the
successfully
same
lifted
thing.
off from Slick 40 at Cape Canaveral Space Force Station, carrying the
Power to
Turksat-5B
nominal.
satellite to geosynchronous transfer orbit. We've throttled down in preparation for maximum dynamic pressure. We're in the throttle bucket.
So they throttle the engines down because the rocket can't move the air out of
Good
the way
views from the
fast enough.
SpaceX ground cameras following the first
Falcon
stage.
is supersonic.
And if you get air compressing on the top of the vehicle because it can't move it out
That's
of the way fast
supersonic.
enough,
The
it'll
Merlin
crunch the
engines are
vehicle.
back up to full
Don't want
power.
to do that. Now, there is fire going up the vehicle. That's totally normal. It's the exhaust from
That's
the fuel
cute.
pumps
And we're through the period of maximum
that's being
dynamic
lit on
pressure.
fire by the rocket exhaust. Because there's low pressure
Everything
behind
continues
the
to
rocket,
look good. Trajectory is
kinda-
nominal. Avionics report systems are nominal.
It appears to kind of crawl up the side of the rocket engine. That's totally supposed to happen, though. It looks like the fire's going up the side because the pressure around the back of the rocket is very low because it's pushing the air out of the way, right? So the
100 seconds into flight, coming up in just under a minute. We're going to have main engine cutoff, where we shut off the 9 Merlin 1D engines.
it's a
We'll
rocket
separate
launch,
the
Octo.
stages,
We're watching a rocket
and
launch
then
out
the
of Florida.
second stage engine will ignite at about the 2-minute and 44-second mark.
MVAC is chilling in.
The MVAC-D engine chill-in call-out. We've begun putting a little bit of liquid oxygen through the turbo pump to get it cold in preparation for second
I'll
stage
explain
ignition.
normal versus
That's
nominal
coming
in a
up
second.
in just about 34 seconds from now.
Okay, so right now what they just called out for M1D vac chill or Merlin vac chill, they're basically priming the second stage engine because it's about to, they're going to
First
need
stage
it
is
in a
coming up
second
on
here.
4G's acceleration, and we're going to begin throttling down to hold 4G's.
Yep, you want a nice steady acceleration. You don't want to liquefy the payload.
Getting ready for main engine cutoff.
Especially if there's people on board. There's nobody's on board this one though. Okay, there's engine cutoff. Stand by for separation.
First stage engine cutoff.
Stage separation confirmed.
Okay, remember how they trickled the fuel into that upper stage engine? They're going to need it right about now. There it goes. Everything look good?
MVAC ignition.
We've got successful stage
Stiffener ring
separation.
separation
The
was
second
perfect.
stage now under power of the single Merlin vacuum engine. Will be coming up on fairing deploy
There's the coast
in
of
a
Florida
little
right
under
there.
30 seconds.
That's Daytona.
Views of the titanium grid fins beginning to deploy on the left as we see the lights of Florida in the background as
Yep.
we head east,
There's
due
Daytona
east
Beach.
from the Cape into our
There's Titusville right there.
transfer orbit parking orbit.
The coastline is right here. So Daytona's up there.
Getting ready for the
That little
camera on
black
second
spot is
stage
the
to switch
airport.
forward to look at the spacecraft and the payload fairing. for
Orlando's
fairing
over
deploy.
here and Tampa's all
Fairing
the way over
separation
there.
confirmed.
Okay. Aerodynamic shell should. There we go. Everything looked good there.
And there you see the two fairing halves have separated,
Kissimmee right there.
falling away from the vehicle.
the
We're
entire
now
peninsula of
exposing the
Florida.
Turksat-5B satellite to outer space. As a reminder, we will be attempting to retrieve these two fairing halves with the help of our recovery vessel,
There you
Bob.
go, Cyclone.
Now, as mentioned previously, these two fairing halves supported the GPS-3 Space Vehicle 5 mission in June of this year. But right now, we're at T plus 4 minutes and counting. Everything continues to go well for the Falcon 9 mission, carrying Turksat-5B into the parking orbit.
So remember, the job of the upper stage right now is to go fast. The first stage is designed to get it up there. The second stage is designed to start going fast.
As
If you
John
look-
mentioned, it's T plus 4 minutes and now 20 seconds into today's mission. We're currently in the first of 2 planned MVAC burns for satellite deployment.
Look at the difference between the second stage and the first stage now. The first stage stopped. It's going 7,300 kilometers an hour. This thing's going past 10,000. You want that number over there? When that number gets above 27, 28,000 kph, that's when it'll be up in orbit. We should get that call in probably about 3 minutes. You know, if everything goes all right here. Yeah, Allie, it is what it is. It's because I wasn't watching the game. I jinxed it. They got wrecked by the Colts, from what I understand.
Narrower plume when the other two engines ignite. Reusability is a key to lowering the cost of spaceflight, which enables more investments in critical scientific research. The Falcon 9, that first stage that is supporting today's mission, will perform this entry burn for the 3rd time, having previously...
How are they able to calculate it, the speed? Well, they have an accelerometer on board, Casimir. It's the same type of thing that, you know, if you have your phone, when you turn your phone, it understands that you turn the phone and the screen changes. It's an accelerometer. An aerospace grade one, but it's the same idea. That's measuring the acceleration. From that acceleration, and then the stage being able to ping off ground stations, the rocket can figure out where it is, and you can determine speed from that. Now, is that the way that SpaceX does it? Maybe. I don't know. They probably wouldn't tell me if I asked them, but get the idea. Isn't it a gyroscope? No, it's not a gyroscope. Accelerometers work differently, from what I understand. Yeah, it knows where it is, so it knows where it isn't. Okay, so guys, we're doing it. We're doing it. Here it comes. The first stage is now orienting itself to do its entry burn. The entry burn is the rocket basically, you know, firing its engines to slow itself down so it doesn't burn up. But this is twin purpose. If you don't know about Falcon 9, you don't know what that thing is supposed to do. Falcon 9 doesn't have a heat shield. It doesn't have one. The first stage, but it's still coming back from space. You can clearly see that it's coming back there. So what it does is it fires its engines just like that. Starts with 1 and goes to 3, right? That's why the flames are kind of oblong, because 3 engines are firing. What it's doing there is it's not just slowing itself down, but it's actually, Falcon 9, if it didn't do this, would encounter some entry heating, and it still does encounter some entry heating. You'll see it when the re-entry burns goes away. But what they're doing with the engines is actually pushing plasma away. They're pushing the re-entry heat away from the vehicle with the rocket engines. And see that? There's plasma accumulation.
Discovery, go at throttle up.
Now, that's the grid fins. It's enough for the grid fins to be able to withstand it, but you can see plasma accumulating on the grid fins right there. That's what those the lighting is. Look at the plasma. This phenomenon in aerospace is called supersonic retropropulsion. It was actually an idea pioneered by NASA. NASA used it for entry, descent, and landing on Mars.
See some of the sparks and soot flying up at the camera there on the left-hand side.
Terminal guidance.
See that? But that was enough for the rocket to be able to withstand. There was some heating
Again, as a quick recap,
they moved most of it out of the way with the rocket engines.
We had a successful liftoff at 10:58 p.m. from Slick 40 at Cape Canaveral Space Force Station in Florida. A successful separation of the first and second stages.
You said the thing!
The first stage is on its way back to our drone ship, a shortfall of gravitas in the Atlantic Ocean.
Stage 2, FTS is saved.
And the second stage is heading to its initial orbital insertion with the Turksat-5B satellite. We're coming up on a couple events, SECO 1 and landing burn.
Yeah, no problem, Casimir. I'm pretty sure it's an accelerometer. What else would it be? It could be an...
Back engine cutoff.
Okay. Cutoff confirmed. Stand by for the landing.
Go at throttle up.
Stage 1 landing burn.
First stage view here.
Got
and
a
the drone ship
successful
view. Let's see what
second
we
engine
got. Hold on.
cutoff.
Hey, Snackless.
Nominal orbit
The
insertion.
landing burn has just started.
Okay, the grid fins are doing some steering there.
And we just heard good orbit.
Back to the drone ship.
Confirmed a nominal orbital insertion.
We have NOI on the second stage.
Now
Stage
waiting on
1
our
landing,
Falcon
leg
to
deploy.
land on drone ship.
Leg
A
deploy.
shortfall of gravitas.
That looked good.
Stage 1 landing confirmed.
And there you have it. That's SpaceX's 99th successful booster landing, as well as
What the
SpaceX's
frick?
78th mission flying a refuel and booster. Our mission isn't over just yet. The second stage is now embarking on its coast phase between the first and second burns of the MBAC-D engine.
That never gets old,
After
man.
the coast phase, we will light the MBAC engine for a second time, a little
I
bit
still
after
get
T plus
goosebumps from
26 minutes.
Expected loss of signal, keep.
We'll see you back here in about 20 minutes at T plus 26 minutes. In the meantime, enjoy some space tunes.
So, guys, all right. It's hard to, like, you look at this and you see it, right? And it's like, okay, yeah, they landed the rocket. But then you realize, like, you don't realize how big this thing is. All right? Falcon 9 doesn't look particularly big. It's 3.7 meters in diameter and about, I don't know, how tall is this thing? 50? It's about 50 meters tall. So, what is that? What is that in America units? That's 3.7 is, I don't know, like 15 feet across. And it's about, I don't know, 150 feet tall. 150 feet is a 15-story building. That's a 15-story building. Landing. That 15-story building was just in space a second ago. And it came back down, shot a rocket engine at plasma as its heat shield, steered itself to a drone ship sitting out in the middle of the ocean, and landed. And yeah, guys, the barge is about the size of a soccer pitch or an American football field. I know what's going on here. I've watched almost every single landing. I think I've missed one over the past decade. I mean, they weren't even landing them 10 years ago, but that's aside from the point. I've seen these things land. I've seen Falcon Heavy land with my own eyes. Like, I was at the first Falcon Heavy test flight. I was at the first mission where they landed a booster, the Orbcomm 2 mission. It still blows my mind every freaking time, dude. That's just like, all right, it's a 15-story building that just landed. It's okay. It's 25.6 bananas wide. There you go. Yep. And see, they got right up to about 27,000 here. They're not, this isn't a parking orbit, so they're not, this is a decaying orbit, so it's not exactly 2,700, but they have slowed down since engine cutoff. That was probably above, or 27,000, excuse me. You need to look at Hired Assassin's link. Yep. Okay. Good view of supersonic retropropulsion. Yeah. Yeah, from WD-40. That's right. Yep. Show the picture of you and Das with the Falcon 9 for scale. I unpinned that tweet forever ago, dude. I don't have the link. Yeah, midget, it's nuts. It's absolutely insane. And this is why I love rocketry. That's so nuts, dude. Like, all right. Yeah, I know, Tomas. Starship's gonna be even crazier. Like, here, I'll show you guys a picture of me and my buddy standing next to one. Like, that's what I mean. You see how big that damn thing is? It's ridiculous. We look small, and me and Das are in the freaking foreground. Matching bro jeans. I can fit underneath them, Fourth Doctor. I'm 193 centimeters tall. I can walk underneath it. We didn't get to, but I can. So for everybody else, it's 6'4". Yeah, that's what I mean, man. This thing is not small. And you know what's crazy? I saw this booster launch. I saw that booster launch and land, and then I got to stand next to it. You know, it's pretty crazy. It's bigger than people think, dude. Oh, hello. That's something else. It's bigger than people think. This hardware is huge. 193, copy bearer. I know, Shadows, I can't. Hey, terms of service. Oh, sorry. Did you see anything? No, sir. I didn't see you staring at the rocket engines again. Good! Yeah, it's alright, Jim. It happens. Stage 2 will be performing a 1-minute burn. Thomas, is it hand check? I'm good. Are we going for super synchronous insertion here? I almost feel that is background GIF worthy. Oh yeah? I agree. I needed to put wiggly engines next to wiggly engines, dudes. It's my splash screen, man. Big mission control, a bunch of wacky things going on in there. Wait a minute. Did you guys see that? My flight director is playing Galaga. That man is playing Galaga. Ridiculous. Ridiculous. I know, Max, it's pretty insane to watch. Where are you, beeps, the sleeps, and the creeps? I've lost them. You know, the bleeps. The sweeps. And the creeps. It's not all he's lost. And well, who knows, we'll all be back for Spaceballs 2. The search for more money. Is this the first SpaceX launch within 24 hours of the last? No, they've done that before once or twice, Demon. Yeah, right, Dr. J? Yeah, that guy's good. Sir, the radar, sir. It appears to be jammed. Okay. About 10 minutes out from second stage engine start. Think they'd get the autonomous spaceport drone ship back in time for the next launch in a few days. Nah, that's why they have a fleet of them. That's why there's 2 of them. Just read the instructions, and a shortfall of gravitas are at the Cape, and of course I Still Love You, literally right now, is sailing back to the port of Long Beach with a booster on it. The one that we watched launch this morning. I'm surrounded by morons. Keep firing, morons! No username. It never came out. I read that Starship is already getting contracts. I've heard whispers of that, Caviar, but I don't know for sure. But yeah, it's unbelievable. Look at that. Almost to West Africa here. 17 minutes across the Atlantic. It's a pretty good time, drummer. I'll be alright, Jam. Really dope? Nice. Question, and please don't judge. Is this a game or real space stuff? No, Peggy, I don't judge at all. We're watching a live track of a rocket flying in space. This is a SpaceX Falcon 9 rocket that just launched out of the Cape. Out of Florida, out of Cape Canaveral, excuse me. I'm trying to be more descriptive. Yeah, we just watched it launch. I'm EJ, I cover these launches. I have, this is a SpaceX launch, and I don't work for SpaceX, but I have permission to cover this stuff from them, which is pretty cool. I'm not sure how many people can say that, but yeah, we covered the rocket launch and we watched the thing go. I cover rocket launches here on Twitch. I'm a STEM streamer, so I teach people about science and technology and all different types of engineering and stuff. And we play engineering video games and whatnot on here. So yeah, no, it's very real. I saw that it was SpaceX's Falcon, but I wasn't sure if it was real or if they had made a game. No. This is the real stuff. When was the last big rocket failure? Oh, it's been a while. Well, actually, China had a rocket not do too well the other day, from what I understand. But in terms of SpaceX, I don't know, man. They really got this stuff down pat, you know, and they do it. It's because they do it a lot, you know. You know, if you make breakfast every day, if you eat breakfast every day, you're gonna kind of come up with better ways to make breakfast quicker, so you can get out and about doing your work, right? You do it more, you're gonna get better at it. Yeah, those were in the you guys gotta remember that CR7 was in 2015, and even VA239 that was in 2019. It's been a while. Nice, Shard. They launch a lot. China launches a lot of rockets into space, man. They're actually going toe-to-toe with SpaceX. Don't you dare, Thomas. Don't you even say that. SpaceX basically invented reusable orbital boosters, so it stands to reason that a few failed to land during development. I mean, for a single stick, like kind of conventional rocket, yeah, I got you. But I'm obligated as a space shuttle fan to say, wait a minute. Refurbishable, I get it, versus reuse. But also, the shuttle had been doing that for a while. But not, SpaceX does it better. Hopefully Starship does it better, man. I mean, dude, they have it down pat, dude. Who else has reused the booster? So NASA's reused boosters technically with the shuttle. The first stage SRB casings can get refurbished, and the shuttle engines can be reused, right? So NASA's done it, and SpaceX. Nobody else has reused the stage for an orbital vehicle. There's Blue Origin with New Shepard. That's a suborbital vehicle. Still impressive. It's hard reusing rockets. We don't count them out. That's it. Rocket Lab has recovered their boosters, but they haven't flown new ones. They've recovered one, Trojan, but yeah, they... does Buran count? That's just getting the payload back, right? That isn't even getting your upper stage engines back. Does the orbiter count as a booster? Because they never got the Energia back. I know there was plans to, but they never got Energia or the Zenit boosters back. I just hope I can travel to space before I die. I hope that becomes possible. Me too, Peggy. Me too. Me too. What will the future of space planes look like when we can get to Africa in less than 30 minutes? Starship? Who launched the most rockets in 2021? I think it's up there between SpaceX and China as a whole. I think the most launched rocket in 2021 was Falcon 9. Because it's funny because Falcon 9 is going toe-to-toe with the Chinese National Space Agency. And they're going toe-to-toe with launches of all their launch vehicles. And it's just Falcon 9, which is crazy. Okay. That's right, Razlak. Is Russia still in the space game? Absolutely, Peggy. I do daily space news segments when I stream detailing what's going on in the space programs around the world. I'm pretty damn familiar with the Russian program. They're doing all right now. Could be better. Could be worse. Doing okay. They're building more spacecraft. Building more ways to get into space. They're working on a couple of different new rocket designs. They're building new launch complexes over there too. They're doing all right. Yeah, that's right, Green. The U.S. is at 49 launches. China is at 52. I followed you for a reason, brother. Excited to see the daily news on everything happening above us. I got you. Peggy, I usually focus on the rockets and the engineering. That's my thing. But yeah, You know, I'll tell you what's going on with different rocket programs. I also I go into spaceflight history and stuff and teach people about like good spaceflight programs, bad spaceflight programs, what's good policy, stuff like that. We do a bunch of different stuff during the news segment. Hey, River Turtle gifted us up to socks. Thank you. I'm looking forward to, I believe, 2 Falcon Heavy launches next year, SLS and Starship. Yeah, Trojan, it's gonna be insane, man. That's right, Caviar.
And back chill underway.
Okay. They're priming the engine again. You just heard the call there for MVAC chill. What that means is SpaceX is
Discovery, go at throttle up.
Jeez, hot dog staple. Holy crap. That was 20 subs, bro. Whoa, wait a minute. You cleared the chat, man. I was trying to read what somebody said. Nope. Thank you very much. I appreciate it. Thank you. That's amazing. I really appreciate it. And WD-40 with a rate of 64. Thank you very much. What was I saying? Oh, yeah. They're starting to chill down the engine. So what they're doing is they're taking the oxidizer and the liquid fuel, so RP1, which is like kerosene almost, and they're opening up the pre-valves and trickling the propellants into the engine. This is more really important for the oxidizer, the liquid oxygen, because you don't want to basically flash freeze the engine. Now, don't get me wrong, the engine is pretty freaking cold right now, but it's not about whether the engine is too cold or too hot. They want to get it at the temperature of the liquid oxygen. So right now what they're doing is they're trickling the propellants into the engine. What that does is it primes the engine, so when they hit the start button, it turns on right away. And it doesn't take a second to go zzz, spool up. I mean, it still kind of does, but and also it makes sure that some of the liquid oxygen that's going in doesn't either A, freeze inside the lines, or B, go through phase change if it's going through a warm rocket engine. Okay, so the engine's chilled down. You just saw the vent close right there. So that means that the engine is at the right temperature and the fuel lines are primed and ready to go. It's not the last one of the year, but thanks for covering every launch this year. I missed some of them, Natch, but yeah, no problem. What you're seeing right there, all this kind of debris that's floating around, is solid nitrogen and solid oxygen. Solid oxygen. The solid oxygen is left over from that venting process that I told you about. The solid nitrogen is from the attitude control thrusters that are on Falcon 9. On the back, kind of near the engine, there's nitrogen nozzles that are, a thruster that's basically hooked up to a tank of nitrogen, and they open and close them, and that's what steers the vehicle. That's what can turn the vehicle around, and then they basically turn it in the right direction and fire the engine, which is what you're about to see here.
Completed its first burn, and that successfully inserted today's payload and second stage into the parking orbit you see on your screen right now. We're getting ready to relight the second stage engine to put us into the geotransfer orbit.
See how the tinfoil over there? It's not tinfoil, it's mylar wrap.
And
you
back
see how
restart
it kind
ignition?
of pulses around? Okay, there we go.
We've got ignition of the second stage engine. We're up on power. Now at this point, the second stage will burn for about 1 minute before shutting down for the second time. This shutdown event is called SECO-2, which stands for Second Stage Engine Cutoff Number 2. And this burn will place the Turksat-5B satellite into the required orbit prior to separating it from the Falcon 9.
The payload and the second stage are still connected to each other right now.
We're going to add about 2,700 meters per second, almost 6,000 miles per hour, to the speed of the Falcon 9 second stage. And that's going to take us well in excess of the standard geo orbit of 35,000 kilometers.
Yeah, Trojan, okay, see, they're
tank pressure is looking good. Engine performance looks nominal.
Getting a little bit of oscillations on the nozzle there. That's fine. That means they throttled it down. That looked right. Everything looked good there.
And back engine shut down.
We've got shutdown of the second stage engine. You saw it briefly there on the screen. And in the background, we heard nominal orbit insertion. So that's the good orbit call-out that we always like to hear. So as a reminder, for those tuning in, the Turksat-5B satellite is still attached to Falcon 9's second stage.
See?
You can just see it a little bit there. We're getting into sunrise as we're coming up over Gabon, or leaving the Gabon ground station, coming up over Heart of Beastock in Africa. So right now we're going to wait a few more minutes for the satellite and the second stage to get closer to the final destination. So we're going to pause the
What Philip
commentary
said
during the
in the
second
shadows.
coast phase, but we'll come back just before stage 2 separation takes place. We'll be back at about T plus 33 minutes and 30 seconds, about a minute before separation.
Okay, we got
And
about
until
5
then,
minutes.
as Ian says, enjoy the space tunes, and we'll see you back here.
So, okay, a little bit on that guy. That guy's the guy that's calling the cast right now. His name's John Inspucker. And I know it seems like it's like, who's that guy? John Inspucker is one of like, dude, he has a lot of experience with launching rockets. He was an Air Force colonel that championed an Air Force program called the Evolved Expendable Launch Vehicle Program. He was the guy that ran the EELV program. Now, okay, if you're a mild space flight nerd, you may have heard that. The EELV is Evolved Expendable Launch Vehicle. It was basically the program for Air Force procurement of rocket launches to launch satellites into space. And he ran the EELV program for a long time. He also oversaw the development of the vehicles for the EELV program. If you're a fan of Atlas V or Delta IV, John Inspucker had help. He was involved in the process in which those vehicles came to fruition, which is pretty dang cool. And then he left the Air Force, and now he's been working for SpaceX for as long as I can remember. Yeah, really cool dude. He's a great teacher. He teaches people a lot about this stuff. I learn all kinds of stuff from him when he calls the cast. He sells propane and propane accessories. That's right. So, who wants an orbital mechanics lesson here? So they accelerated at the lowest point of the orbit, or perigee. Perigee refers to the lowest point of your orbit around Earth. They accelerated to, let's see, geostationary transfer, I don't know, it's probably like 22,000 miles an hour. You could probably get an idea from over there, right? They accelerated at the lowest point in their orbit. When you accelerate at the lowest point of your orbit, in the direction that you were already going, you're compounding the force. You're compounding, you're adding speed to the speed that you already had. When you do that, right, that changes an orbital parameter called eccentricity. Now, what's eccentricity? Well, orbits can really only be 2 types of shapes. I mean, if you really want to be technical, it's 4. But for the sake of keeping it simple, orbits can be a circle, or they can be an ellipse. They can be a circle, or they can be an oval. That's it. The other 2 are, they're suborbital, which means you don't have a shape, which is just an arch, which means you're coming back down. And then there's escape velocity, which means you're leaving the planet, that you're leaving the planet's grav well. This, burning at perigee, at the lowest point, compounding your speed, accelerating at perigee, which is already the fastest point, all right, makes a more eccentric orbit. It pushes on the other side of the world. You're burning here and the Earth is here, right? You're going to make the orbit go elliptical in the direction on the opposite side of where the rocket is. Spaceflight's a little backwards like that, right? But in doing a prograde burn, so burning in the direction that you're going, at the fastest point that you're going, is going to change the eccentricity of your orbit. The highest, right now, Falcon 9 is in what's called a geostationary transfer orbit. The highest point in the orbit is where the satellite's going to live, and the lowest point is where the engine was started from. This is a very elliptical orbit. The apogee, or the highest point in this transfer orbit that they're on right now, there's the satellite right there. The highest point is 23,500 miles that way, or at geostationary altitude. That's about 38,000 kilometers straight up. The lowest point of this orbit is about, 170 kilometers, or about 100 miles. So we have 23,000 miles that way, 100 miles that way. It put itself into this orbit with that last burn that we saw. The idea is that the second stage, the highest point of your orbit, right, is where the satellite's going to end up living, and the lowest point is where the stage is going to come back down and burn up in the atmosphere. Now, so if that's the case, why are they deploying this right now? Well, what the satellite is going to do is it's going to coast out to the highest point in this eccentric orbit, right? In this elliptical or oval-shaped orbit, it's going to coast out to the highest point. When it gets to the highest point, that's when the satellite is going to fire its thrusters. And it's going to take that 100-kilometer perigee, lowest point, and it's going to make a circle out there. And that circle is going to be at geostationary altitude, and that point is going to be 42 degrees east longitude, which means it's going to hover over Turkey because it's a Turkish communications satellite. It's going to appear to hover. The type of orbit that it's going into is geosynchronous, meaning that the satellite is in a type of orbit that matches Earth's day-night cycle. So the orbit at 23,000 miles up, or 38,000 kilometers, is 24 hours. So the Earth spins, right, and the satellite spins with the Earth, so that if you looked up at the sky, the satellite would just be hovering in one spot, or at least it would appear to be. The racing is at the end of this. And that way, you basically have an antenna, like Turkey will always have an antenna over Turkey where they can use to communicate with a bunch of different things. It's really handy to have. And the type of transfer orbit is called a geostationary transfer orbit. It's a transfer orbit that with its kind of end of the line at geostationary. So right now, you should see the satellite pop off here in a second. Let's turn them back on. Stand by for the call here. They're going to use basically a spring decoupler here. They have a latch that opens.
Good view right here.
And springs just pop open and the satellite just goes forward. The decoupler doesn't have to be complicated. You want to go for the simplest type of thing, but you should
Payload
see
separation
there it
confirmed.
goes. You see the springs decompress?
And there you have it. We've received a successful separation
That
of the
little guy right there in the
Turksat-5B
center?
satellite from the
That's the
Falcon 9
thruster.
second stage,
Bye.
which now brings today's webcast coverage to a close.
Expected losses signal.
Thank you to
keep on.
Airbus for entrusting us with the Turksat-5B satellite. A big thank you to the range and the Federal Aviation
See
Administration.
the
We
ring
really
on the
appreciate
springs?
having your support for today's mission.
Pretty cool, huh?
It's been an exciting day here at SpaceX, having supported 2 missions within roughly 18-hour time frame. But as we mentioned before, it doesn't end there. Be sure to join us for the next cargo resupply mission to the International Space Station with the CRS-24 mission, currently targeted for Tuesday, December 21st at 5:06 a.m. Eastern Time.
And we'll be
And
covering
to all our
that.
viewers, thanks for joining us, and we'll see you again very soon.
I just want to point out that we're watching you're watching a live streamer who is bringing you a live stream of a satellite floating around in space in real time. Just gonna point that out, you know, like just pointing that out. Yeah, that we just got a live view of a satellite being deployed in space. Huh. That's pretty neat. Yeah, that's pretty neat. Yo, dog, I heard you like streams. But did you see the springs decompress on the decoupler? They basically have a latch that opens and a spring that decompresses, and it pushes the satellite away. Now, if you noticed, more keen-eyed of you will notice that the second stage is kind of doing this. When that spring decompressed, right, equal and opposite reactions. It pushed the satellite away, but it also pushed the second stage away too, and that's why the stage is kind of doing this. They pushed away from each other. Every action has an equal and opposite reaction, which means when that spring decompressed, it applied equal force to the satellite and the payload in the second stage. To the satellite and the second stage, so they pushed away from each other. And you could see some of that force being imparted on the vehicle when it went by, it kind of drifting away a little bit. Do they not deorbit the second stage? Well, Kaylee, we're in that eccentric orbit, like I told you. The eccentricity of this orbit has perigee at about 100 miles, so 160, 170 kilometer, where their parking orbit was, right? 160 kilometers up is decaying. That stage, they could just leave it. That's why the stage is just kind of floating around. That stage stays in that transfer orbit, and then every time it gets to perigee, the lowest point or fastest point in its orbit, it hits a little bit of the atmosphere because that orbit is very low. It's going to hit a little bit of the atmosphere, and it wouldn't be enough to slow it down right away, but it's going to keep hitting it and keep hitting it and keep hitting it and keep hitting it. All right? Every time it hits the atmosphere, it slows down a little bit at perigee. It's doing the opposite of what it did to put the satellite out there. Okay? If you accelerate at perigee, you're going to push your apogee higher. If you decelerate at perigee, you're going to push it lower. And the stage, hitting the atmosphere every time, is decelerating when it hits the atmosphere, when it gets to its perigee. So that second stage eventually will come back down. it'll re-enter. And when it re-enters, it's not, none of it's going to get near the ground. It's going much too fast. It's going to come down in a couple of months, guys. It'll probably be down sometime in the middle of 2022, but it'll stay up there for a while. It's going to take a second to take that 23,000 mile apogee and get it to suborbital, right? Yeah, Ninja, right? Don't they fire the Stage 2 RCS at S2's apogee to re-enter on the first pass? They could, Graph Shark, if the battery life lasts long enough. Sure, they could do that, but it'll naturally decay too. Knowing SpaceX, they probably have the option to do either one, because you know what, man? One solution might not always be the best one. You might. It's better to have two potential solutions to a problem, then you pick which one is best for the application, right? That's right, Peggy. To the ocean, Duzu, I do not think any part of that second stage is going to get anywhere near the ground. It'll burn up. It'll completely burn up. Yeah, it'll burn up. It's not getting near the ground. All of it will just. People don't realize how big space is. Even if it's stayed up there, it won't make a big difference. There's 2 NASA stages that have been up there for 10 years or more. Yeah, that's. Some Saturn V stages are still floating around out there, Ace. We just don't know where they are, but they're floating around the sun. There might even be a lunar ascent module sitting out there somewhere. We don't know. We can't track it. Some debris, I mean, when you're trying to track an object that's the size of a freaking walk-in closet from 250,000 miles away, it tends to get a little difficult. And you know what the messed up part is? You're right. 250,000 miles away is a lot for you and me. That's nothing. That's our backyard on the scale of the solar system. It's crazy, right? Yeah, that's correct. It's like a speck of dust. That's right, Peggy. The scale here is insane to understand. It's pretty cool. But anyway, guys, I hope you enjoyed Turksat. I'm going to be here for CRS-24, and I cover most rocket launches. We'll be here for James Webb even on Christmas Eve. I don't know why NASA decided to launch on Christmas Eve. My family ain't gonna like me for that. I am gonna get flack for that, but it's all right. James Webb is worth it, man. I hope you guys enjoyed it. So we got CRS-24. SpaceX is gonna launch another one before the end of the year. Wait for it. Another one. Another one. Another one. What about New Year's launch? Oh God, I don't know. Family. Assuming Webb doesn't get delayed due to a problem just now. Oh, don't say that. Don't say that. Don't say that. Don't say that. Just say you're watching for Santa on the NASA channel. Yeah, Shadows. You know what? That's a really good idea. It's a really good idea. But Apollo 8 did a thing on Christmas. Yeah, and I wasn't alive, so I didn't have to see my family during Apollo 8 because I wasn't alive. I'm alive now, though. I think. So they're inviting all of us to a Christmas Eve party. Yeah, at 7 in the morning on Christmas Eve. The gimbal is real. Yeah, you see that up there, Devils? A little distracting, isn't it? Hot Dog's like, I was alive during Apollo 8. I'm a little jelly, to be honest with you. James Webb is like a good Santa's gift. That's right. Not Jab is gifting this, is continuing the gift sub they got from Secret Code. Thanks, Jab. I appreciate it. Oh, I was wondering what you thought of the 6 RVAC engines. Kaylee, we came up with a couple of theories for why they want to add more engines to Starship. The first one is because Starship is heavy. Not super heavy. It's heavy, and I think they might want that extra TWR to get better payload to low Earth orbit at the behest of range. But I mean, if you're moving fuel into orbit to refuel starships, you're going to need all the thrust that you can get. That's what I kind of thought. It might be true. The second theory that we came up with for Starship needing 9 engines now instead of 6 is SpaceX basically wants to put whatever you can fit in Starship's payload bay you can get into space. I think that's what they're trying to do. That could mean theoretically boosting Starship up to like 150 tons of pop into space, which is just insane. My mom told me she watched the Apollo 13 fail on television. Her school planted trees for each one of the astronauts, and they're still there and huge now. I don't think many people know about the tree in my hometown, but it's cool. Oh, she's probably talking about Apollo 1, Peggy. Yeah. Doesn't the extra vac burning mean more of its delta V expended to get to orbit is spent burning at a higher specific impulse in terms of average specific impulse through the ascent? Yeah, Grav Shark, yeah, I suppose. But they also extended the tanks, too. And we actually, in